Hi everyone. Today we're going to study isomorphism of graphs. The simple graphs capital G sub 1 equals the elements capital V sub 1 and capital E sub 1, and capital G sub 2 equals the elements capital V sub 2 and capital E sub 2 are isomorphic if there exists a one-to-one and onto function f from v sub 1 to v sub 2 with the property that a and b are adjacent in g sub 1 if and only if f of a and f of b are adjacent in g sub 2 for all a and b in v sub 1. Such a function f is called an isomorphism. Two simple graphs that are not isomorphic are called non-isomorphic. In other words, when two simple graphs are isomorphic, there is a one-to-one correspondence between vertices of the two graphs that preserves the adjacency relationship. Isomorphism of simple graphs is an equivalence relation. Example 1. Show that the graphs G with elements V, E and the graph H equals the elements W, F are isomorphic. These are the two graphs, graph G and graph H. The function f with f of u sub 1 equals v sub 1, f of u2 equals v sub 4, f of u3 equals v sub 3, and f of u sub 4 equals v sub 2 is a one-to-one correspondence between capital V and capital W. To see that this correspondence preserves adjacency, note that adjacent vertices in graph G are u sub 1 and u sub 2, u sub 1 and u sub 3, u sub 2 and u sub 4, and u sub 3 and u sub 4, and each of the pairs, the f of u sub 1 equals v sub 1 and f of u sub 2 equals v sub 4. This is the first pair. Second pair, f of u sub 1 equals v sub 1 and the f of u sub 3 equals v sub 3. This is the second pair. Third pair is f of u sub 2 equals v sub 4 and f of u sub 4 equals v sub 2. And last pair, f of u sub 3 equals v sub 3 and f of u sub 4 equals v sub 2 consists of two adjacent vertices in graph H. Example 2. Show that the following graphs are not isomorphic. Both graph G and H have 5 vertices and 6 edges. However, H has a vertex of degree 1, namely the vertex E, whereas G has no vertices of degree 1. It follows that G and H are not isomorphic.